Hello my dear friends, welcome to the subject of statistics for the class 12th English medium, part 2, chapter 5, differentiation, presented to you by Vitan sir. Today we are going to study a new topic, that is elasticity of demand. Now this is the topic which you have already studied in the 11th economics, but how to calculate that elasticity of demand based on statistical methods, that we will study in this tutorial. Now, the ratio of percentage change in the demand of the commodity due to percentage change in its price is called elasticity of demand. But this is the definition, and this is the actual formula which is given in your economics textbooks of 11th. So this is pretty basic. What we are going to do is that by using the differentiation technique for calculation of elasticity of demand, we will follow the below formula. That is, elasticity of demand will be negative P upon X into dx upon dp. Okay, now first important thing, the elasticity of demand, the demand curve has a negative slope. So that elasticity of demand is always negative. So to calculate it is in a positive manner, we have added a negative sign in front of the equation. As you can see in the previous slide, we also added that negative sign. So that same sign we have to add here. Now P is the price, X is the demand. So naturally price and demand are to be compared here to calculate the elasticity of demand. So P upon X multiplied by dx upon dp. Now if you remember all the previous sums, usually it is dy upon dx, that is dx is in the division. Whether it is dy upon dx, dc upon dx or dr upon dx, dx is always in the division. But this time dx is in the numerator, dp is in the denominator. That means we don't have to calculate the differentiation with respect to x. In this equation, we will be calculating differentiation with respect to p. So usually whenever we have x square, we make it 2x. Now we will have p square and we will make it 2p. Okay, getting the drift here. Let us check one or two illustrations so that we can get it more clear. Okay, we will take one illustration. Illustration 30, the demand function of a commodity is x is equal to 50 minus 4p. So here function is x, variable is p. We have to find the elasticity of demand when price is p is equal to 5, and then we have to interpret it. Okay, what we are going to do, we are going to write down the demand function first, x is equal to 50 minus 4p. Next we are going to differentiate it, that is dx upon dp. Okay, so x is the will be numerator dx and p will be denominator dp. So 50 will be 0, this is the differentiation basic. Negative 4p, now here p is in the denominator, that means p will become 1 and negative 4 will remain, so the dx upon dp here will be negative 4. Just remember how we differentiate when x is given and follow the same formula, except this is not x, this is p. Don't worry about it much. Now we will write down the formula for elasticity of demand, that is negative p upon x multiplied by dx upon dp. So we will start with negative p will be as it is, x is 50 minus 4p and dx upon dp is negative 4. So we will write it as such. Now to simplify, we will multiply negative 4 with p. But as you can see, there are two negatives. First one is in front of p and second one is in front of 4. So negative negative will become positive, so negatives will be cancelled. 4p upon 50 minus 4p. Next, the price is p is equal to 5. That thing we will put into the equation here. Elasticity of demand will be 4 multiplied by 5. Wherever p is there, we will put 5. Divide by 50 minus 4 into 5. The p is price, the x is demand. Sometimes in the question units are given, so we will put those units in place of x. In the question p is given, price is given, then we will put that value in place of p. So remember that thing. Elasticity of demand is 4 into 5 divided by 50 minus 4 into 5, and we simplify it, 20 upon 50 minus 20, that is 20 upon 30. To simplify it, we will get 0.67. To interpret it, we can say that when price changes by 1%, the demand changes by 0.67% in the opposite direction when the price is rupees 5. So when price is 5 rupees and if we change the price by 1%, the demand will change by 0.67% in the opposite direction, because the answer is positive, so demand always goes opposite. If the answer would have been negative, then it would be the same direction. Okay, we will take one more example. This is a very short tutorial, so we will just take this last example, and next time I will start with a very important topic. The illustration 31, the demand function of a commodity is P is equal to 12 minus root x. Okay, this time function P is given. So P is equal to 12 minus root x is given. We have to find the elasticity of demand when the price is 9 units. Okay, in the previous question, the price was 5 rupees. Right now, the price 9 units question is given. That means the question is given for units and not price. First of all, we will write down the function as it is. P is equal to 12 minus root x. Okay, second thing, here P is given first. So right now we are not going to calculate dx upon dp. We will calculate dp upon dx, the usual method. So dp upon dx. Okay, now you must remember that 12 becomes 0 and root x, in the very initial tutorials I told you guys that root x becomes 1 upon 2 root x. Remember that thing. So root x will become 1 upon 2 root x when differentiated, and when we remove 0, the remaining thing is negative 1 upon 2 root x. Now, in our formula, we don't need dp upon dx. In our formula, we need dx upon dp. So we just need to inverse the value here. So when I take dx into numerator and dp into denominator, the 2 root x comes into numerator and 1 goes into the denominator. So the remaining value is negative 2 root x. Okay, this is possible. This we can do. This is statistics. As far as you follow the rules, you can do anything. Now, elasticity of demand here is negative p upon x into dx upon dp. But this time we have the value for p, that is 12 minus root x. So that we will put and multiply it with dx upon dp negative 2 root x. Now we will take everything into numerator and put it like this. We will keep it as it is. Now in the question, the demand is 9 units. So units basically means x, that is x is equal to 9. So wherever x is there, we have to put 9 into the equation. So 12 minus root 9 into 2 root 9 is 3. So 12 minus 3 into 2 into 3, that is 12 minus 3 into 6 divided by 9. 9 cancel, the answer remaining is 6. So your statement here will be to interpret it, when price changes by 1%, the demand changes by 6% in the opposite direction when the demand is 9 units. So when you demand 9 units and the price is changed by 1%, the demand will change by 6%. So that means the demand changes more than the change in the price. Okay, so with this I end today's tutorial here. This is not very important topic. Actually, this is one of the topic given in the textbooks. I am explaining it, but usually it is asked more in MCQ or short answers. The big questions usually are from the maximization or minimization, and the additional topic of that maximization and minimization we will learn in the next tutorial. So till then, stay tuned, stay home and stay safe.